And we're live. Hey, everybody. Hope we're all doing good. What a day yesterday was, huh? We had a lot of fun. We learned a lot. We also got a little bit stuck. And by we, I mean me. But thanks to all your help and perseverance, we did it. We pulled through and we did that record collection exercise. So that went wonderful. Hey, hello to Nicaragua. Hope you're doing good. Lovely to see everybody here today. Howdy. Yeah, hope everybody's having a wonderful day. As said, today we're going to be continuing. Hello from India. Hello to you. Yeah. Hello from Chile. Hey, good to see everybody. All right. Well, thank you all so much for your patience with me yesterday. We got a little bit delayed. So what I want to do today is do a little bit of loops and a little bit of recursion, and two, take us into ES6. ES6 is, of course, the next stage of JavaScript, which is, well, we're going to cover that in just a minute. So before we do that, let's dive right into loops, do a couple of exercises. We're not going to do all of them, so the rest will be homework. Then we'll continue into ES6 and then finish off for today. Tomorrow, I made a small schedule change. I hope you saw it. We're going to be continuing with ES6 tomorrow. Then on Monday, we'll be continuing with regular expressions. And then on Tuesday, we'll do the palindrome project. So let's do our best and dive right into while loops. So let's do some loops. If you haven't done loops before, what they are is a declaration of code that gets run, hopefully, more than once. So let's start off with an example. Let's take our definition here. So we've got a variable called I, which is set to 0. We will call while I is smaller than 5. And instead of pushing to an array, let's console log I. Now, you can see here what's happening is we're printing out 0 because, of course, we haven't changed the value of I. We're just continuously and forever. This is infinitely printing out the value 0. It's never going to stop. So what happens here is, in fact, let's call console log hello. And you'll see what happens here is we never actually make it to printing out hello. And that's because what we're doing here is we're saying, hey, is I smaller than 5? If it is, then run this code and go back and check again. Is I smaller than 5? Which it is. So we go back again and again and again and again and again and again forever. Now, the problem is this isn't the best piece of code, is it? So what we want to do is change the value of I so that the loop eventually ends. Let's do that real quick. Let's do an I++. Now let's have a look at the code again. We're saying, okay, I is 0. Is I smaller than 5? Yes. So run this code. We print out the value of I, which is 0. We go back. We add 1 to I, and then, oh yeah, I'll make it a little bit bigger. My bad. Thanks, Catherine. Yeah, making that a little bit bigger. Yeah. So sorry. So we add 1 to I, we go back, check whether I is smaller than 5. I is now 1, so it is still smaller than 5. So we print out I again, that's how we get the 1. And then we go back, we add 1 to I is now 2, I is still smaller than 5, console log the 2, add 1 to I, go back, I is now 3. 3 is smaller than 5, print out 3, add 1, it's now 4. 4 is smaller than 5. We print out I, which is 4, and we add 1 to I. I is now 5. Is I, or 5, smaller than 5? So 5 is not smaller than 5. And so we don't print out the value. We just skip over and continue from here. So 0, 1, 2, 3, 4, 5, and just finishing right there. So that's how loops work. Now, let's add the numbers 5 through 0 inclusively in descending order to my array using a while loop. Just going to have a sip of water. Had a lot to cover today. Let's do our best. So we want to add the numbers 5 through 0. So what we can do is change this around. How about while I is bigger than or equals to 0, and we'll start out at 5. Instead of adding 1 to 5, I'm going to I'm going to subtract from I. So check it out. Now it's going 5, subtract, 4, subtract, 3, subtract, 4, subtract, 5, 4, 3, 2, subtract, 1, subtract, 0. And because 0 is bigger than or equals to 0, that's why we can still do one more loop here and then print out hello. But that's not quite what the exercise wants us to do. We want to add the numbers 5 through 0 to this empty array here. So let's do that. MyArray.push I. So we will add that number to the array. Let's print out that array and see how it looks. 5, 4, 3, 2, 1, 0. That's how we do that first loop. Let's run our tests. There we go. Pat. We're going to do 1, 2, 3, 4 more of these and then move on to ES6. So now we'll do 4 loops. And again, you might have done these already. I just want to make sure that we've all covered loops before we move on to ES6. So a for loop is similar to a while loop, except we do a heck of a lot more in there. So let's, what we do here is we have a for. It looks very similar to before. But inside these brackets, we're going to define 3 parts. First, a variable called I. We will set it to be 0. Then our condition, just like inside the while loop. And then the part that will be run every loop, the I++. So made up of 3 parts, declaring the variable that will loop through, the condition to leave the loop, and the change between every step of the loop. Let's console log it and see what's happening in here. It might seem very similar to before. 0, 1, 2, 3, 4. So let's use a for loop to push the values 1 through 5 onto my array. So 1 through 5, we're almost there. What I'm going to do here is make this bigger than or equals to 5. 0, 1, 2, 3, 4, 5. Perfect. Let's push that onto my array. We've done in previous sections. Console log that for safety. And there we go. Values 1 through 5. So this loop actually needs to start at 1. There we go. With that done, let's run our tests. Yes, pat. Next challenge. Now, we're going to be doing the same thing, but this time we're only going to push in the odd numbers. Now, folks, you might have tried different ways of doing this. I'm going to do it in a way that I thought of. So we will loop from 0 to 10. And I++. And if, somebody's Essa's already saying, thank you, Essa. We'll be using the remainder. That's right. So if I remainder 2 is equals to 1, that is, it's an odd number, we will push my array. We will push that onto my array. Let's console log that and see how it is. Folks, if you're having some problems with the connection, try setting the quality to the highest value, please. So remember, questions, we'll be asking lots of questions during this, so please ask them at the end and we'll do a Q&A section. But anyway, there's our odd numbers. So that looks good. The odd numbers from 1 through 9. Let's run our tests. Yes, pat. Let's keep going. Now, the next exercise, we're actually going to make this be, I'm going to skip a little bit ahead to this exercise. nesting for loops. Because yes, you can run a loop inside a loop, which sounds a little bit weird. Let's give it a try. So let's see what we want to do here. First of all, let's see what we want to do. We want to modify the function multiply all so that it returns the product of all the numbers in the subarrays of R. So let me just take this real quick. We've got an array here made up of 3 parts. One is this array, then we've got this array, and we've got this array. And what we want to do in this exercise is multiply all of those numbers together. So that's why we start with product being 1. Next, we're going to loop through each array here. So we're going to use that for array. Let I equals 0. I will be smaller than R dot length minus 1. That's how long the array is. And we will I plus plus. Now, let's console log our position I. What am I doing wrong here? 0. I starts at 0. I is small. It must be smaller than array length minus 1. Sorry. I must be smaller than array length. That's it. So there's each subarray. Good. Whew. Now, let's have a look at what if we wanted to loop through inside that loop. What if we wanted to loop through each array that is inside? What we can do is let's call a variable called const sub R, subarray, is equals to R position I, or index I. And we're going to do the same thing, a for loop. And now we need a different variable. Let's go with J. This is pretty commonly used, I and J for loops. So J must be smaller than subarray length. And J will be, whoops, sorry about that. Let's remove that logo. Thanks for pointing that out. So J plus plus. So we've got a subarray inside here. Now, let's console log that. And remember, we can access nested arrays by going array. Yes, array I. And then inside that, we can access J. Now check it out. We've printed out 1 and 2. We finish the loop, go back to the outer loop. I is now 1. We have our new subarray. We loop through that subarray, print out 3 and 4. Finish, go back out. I is now 2. So our subarray is this one here. We loop through that and print out 4, 5, 6, and 7. Now, that's all well and good. But now what we want to do is multiply. So we want to multiply product by, how do I find my, So remember, with the compound assignment, we can do that. Product times equals, array I, J. So now what we're doing, let's go ahead and console log that. See what we get. 5,040. So 1 times 2 times 3 times 4, blah, 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 is 5,040. I'll take its word for it. Now, we will run our tests. And don't worry, folks, if this looks really weird at first, try it out. Watch the video again. The recordings always go up on YouTube. Ask questions on Discord and in the forums. Let's run our tests. There we go. Pat, pat. All right. Almost done with JavaScript basics. The last one I'm going to cover is recursion. I said the rest will be homework. So recursion. What is recursion? Recursion is let's say the functionality of using a function to call that same function's to call that same function. So before looking at any of this, let's have a look. We've got our multiply function here, and we did this before. We've got an array, and we're going to loop through all of the members of that array and multiply them by one another. Next, what we can do is either use this or use the function to call itself using something called recursion. But before we look at the examples, let's try and figure it out ourselves. So we're going to write a recursive function, sum, which we see here, that returns the sum of the first n elements of the array R. So after this one, we will move on to ES6. So let's console log. Let's make an array and define it as 1, 2, 3. Now, summing all three of these up should give us 6. Have a look. Sum my array, and let's sum up the first 3. Right now, that's giving us undefined because this function isn't returning anything. So how could we resolve this with a loop? We could have a result and add to it as we go through each member of that array. I'm not going to do this, but instead we're going to be using something called recursion. So in order to do that, what we're going to do is let's return sum of array and the value n minus 1 plus the member sum, array at n minus 1. I'm getting an error saying maximum call stack size exceeded. My goodness. What are we actually trying to do here? We're getting this member of the array, which is in this case would be 3, and summing it to this function here, the return value of this function. However, if I'm doing this infinitely, we're going to get this error. Maximum call stack size exceeded, because we're just calling sum again and again with n minus 1. So it's going to be 2, then 2, then let's see, 2, then 1, then 0, then -1, and so on and so forth. So what we want to do is actually check if n is equals to 0. In that case, instead of returning this, we're going to return 0. Let's check. What we're going to do here is a couple of things. Let's do some console logging. Console log always feels great to me. N and array at member n. Array at member n minus 1. And let's use different numbers for this, just for the sake of argument. 5, 2, and 9. So in the first call, let's put this all the way up. Sorry, folks. There we go. So in the first call, n is 3, which makes sense. And the value at this position is 9. We go through, we will return this value plus this, which is called again with now the value 2, which we see printed here. And that array value is also 2. Go through, n is not 0, so we keep going. We'll return that value and call again, but this time with n minus 1. So this is now 1. And print out 1 and the 4. Folks, sorry, I'll scroll up. We're doing replace loops using recursion. Just to answer this question here. Now, where were we? Yes. Array position 0. And because we're going to be calling array at 0, n is 0, and we will return 0. So instead of calling this function again, we never get here. And that's how the recursion stops. There are a couple more exercises on recursion. That's how we will get to the end of this base case, as Essa is saying here. How do we decide the base case of the recursion? It depends on the use. In this case, we get to the end of the array, which is when n is 0. Now, this will take some time to grok. I would recommend doing this and the other exercises to do with the recursion. Watch this video again. It's going to be on YouTube a couple of times, and we'll get there. Srinu's asking, why for the 0th index we're getting undefined? That's because I'm getting Rn minus 1. So n in this case is 0. So I'm trying to get the array place at -1, which is undefined. That's why. Oh, it looks like the bottom of my screen is covered up. Let me move my window a little bit. Hope that's better. Oh yeah, that looks better. Okay. With that done, let's run our test and see how it goes. Phew! Pat, pat. Now, I will submit and go to the next challenge, but instead of doing the profile lookup, I'm going to go back to Free Code Camp, go back to my JavaScript exercises, and take stock of where we are. We've done a lot of JavaScript basics. We've covered a lot of stuff in the last week and a half, and I'm proud of us. We're doing great. The homework for today will be to finish the rest of these. Some of these will involve loops, recursion, and some other operators like getting random numbers. I believe we can do this together, but we're not going to have time to do these in the lessons today because we've got 6 weeks and we got to go get through all of this. So instead, we're going to move on to ES6, which is the purpose of today's lesson. So we're caught up now. So ES6 is a new flavor of JavaScript that's slowly being incorporated into modern browsers. The reason it's called ES6 is the name of the language, ECMAScript, and it's included a whole new bunch of features onto JavaScript that make it a lot more powerful, and in my opinion, in some cases, even easier to read. You might be wondering which browsers support ECMAScript, and to that I can say most of them do. So again, any questions you might have, we will have a Q&A at the end, so bear with me, folks. So ES6, as said, came out 6 years ago. My goodness. That's why it's called ES6. No, it's not. I'm kidding. 7 years ago. I can't do math anymore. It's 2022. Anyway, so we'll be learning these new features, including arrow functions, destructuring, classes, promises, and modules. We've got a lot to cover, but we're going to get through it. So we're going to hop right in. We're going to start with ES6 and go right into it. And our good friends var and let are going to be here. And in this lesson, we're going to focus on scope and how redefining these works. Let's look at what we're doing here. We're going to call check scope. We've got a variable called I, which is a string called with the value function scope. If true, which it's always true, so this code is always going to be run, I will be reassigned the value block scope, and will console log block scope is and the value of I. Then, once that's done, we will console log function scope I is I again, and we'll return I. So let's console log, let's call the function check scope. So let's see what happens here. Block I says that, so first we print out here, block scope I is I, which is block scope. And then out here, function scope I is I, which is block scope. Now here comes another fundamental difference between var and let. If I use let here, still works. We can change the definition of of I. So in both cases, I is redefined to block scope. But if I call let here in again, now we're letting I only within this scope, inside this if statement, be redefined. With var, that's not the case. So again, That's the difference between var and let, another difference between var and let. Yes, we're redefining it, but within a new scope. We can redeclare a let variable if we're in a different scope, which for the if statement, we are. And that's why inside here, I has a value block scope, but when we go back outside, we're back to function scope. Again, with var, this gets redefined and stays redefined. But with let, it's within that scope. Let's look at our exercise. Fix this code so that I is declared in the if statement is a separate variable than I declared in the first line of the function. Be certain not to use the var keyword anywhere in your code, which we're not. This exercise is designed to illustrate the difference between var and let, assign scope to the declare variable. When the programming a function similar to the one used in this exercise, it's often better to use different variable names to avoid confusion. Absolutely. So we've done it. We've redeclared these to use let instead of var. Let's run our tests. There we go. Pat, we're 3%. We're already making huge progress. Now, this is something we've covered before. Const, with const variables, again, these are pretty predominantly used in ES6. With const variables, we can't change the value of the variable, but we can mutate them if they're mutable. So an array is declared as const 572. Change the array to 257 using various elements assignments. So again, we can't change the variable s's value, but we can change the values at each position here. So let's do that. S0, remember that's the first index, is set to be, we want to set it to be 2. S1 is set to be 5. And S2 is set to be 7. Let's console log s to see how we did. So we don't get an error. We get 2, 5, and 7. Omran's asking, can we push to const? Yes. Yes, we can. Because we're changing the variable. We're mutating it. We're not changing the value. Okay, that's done. Let's run our tests. There we go. Pat. Let's keep going. Whew. Ah, yes. If you can, always, Free Code Camp is run by volunteers. Only if you can afford it. They're very grateful if you give them a couple bucks a month. So, objects, just like arrays, are mutable. But here's the thing. We can actually use a function called object.freeze to be able to freeze that object and make it unmutable or immutable. So let's see what we've got here. We've got an object called math constants, and it's got a key of pi and a value of 3.14. And here we've got something new, try and catch. What's going to happen is that in this block of code here, we're going to try to run it. If there's an error, instead of throwing the error and this program stops, it'll say, hey, catch that error if there is one, and console log it. Now, we then return mathconstants.py. Let's console log pi. Here we're running, change the value of mathconstants.py to be 99. And we can see that that's done here, and that's totally fine. But in this exercise, what we want to do is freeze math constants so that we can't change the value of pi. So with that, we're going to use object.freeze, and we're going to pass to it as an argument math constants, the object. Now let's see what's happening. First, we're console logging an error. Cannot assign to read-only property pi of object. So what it's saying here is, hey, you made this, you froze this object. You tried to change its value, but we threw an error because we said, hey, you can't do that. It's frozen. And if we console log pi, we can see here, it's still 3.14. So that's the use of object.freeze. If we ever want to freeze an object, we can use this to do it. Let's run our tests. And there we go. Pat, 10% already. Look at us go. All right. Remember, folks, if you've got any questions, I'll have a dedicated Q&A session at the end. Next comes one of my favorite parts of ES6, a new way to declare functions. Let's take a look at what we've got here. We've got var magic, which is a function, and it returns a new date. Let's console log that. Console log magic. Remember, to call the function, we need the smooth brackets. And the date is Tuesday, January 18th, 2022. This is the current time here in Vienna, Central European Standard Time. So that's going to look different for you depending on where in the world you are, because your computer's smart and knows where you are, which sounds a little bit creepier than it should be. Anyway, so what we can do here is, the reason I like arrow functions is because I find them as an exciting new way to be able to declare functions, and I don't like typing out the word function. I'm lazy. So here's what you can do. Instead of writing out function, what you can do is have the smooth brackets and an arrow using an equal sign and a bigger than sign. Yanabi94 is a fan, I think. Nice. So yeah, all I did, let's do it again. This is one way of declaring a function, and this is the ES6 way of declaring a function. So Galbrush is asking, what is the new in the return new date? That I will get to later, I promise. We're declaring a new instance of a class. Bear with me, folks. So, yes, this is a new way to declare a function. There's something else that arrow functions offer. This function has only one line, right? We can see that, return new date. So instead of typing out return new date, what we can also do, and make this even shorter, is remove the curly brackets, remove the return, and put that up here. Now, this is also a way of defining a function, and by removing the curly brackets, ES6 knows to automatically return whatever is in there. Let me give you an example. Instead of new date, let's type out the letter A. So it will, by doing it in one line without the curly brackets, it will return that one line function, that one line value, which is pretty cool. I'm a fan. But again, let's go back with some nice Command Z. That's one way to declare an arrow function. And if it's a one-liner, we can remove the curly brackets and the return. Now it's truly a one-liner. So our exercise is to return a new date using the return function, the arrow function syntax. Also, make sure nothing is defined using the keyword var. Yes, this is a const. Hey, a sorcerer. I like ES6. So that's all done. Let's run our tests. And there we go. Pat. On to the next one. How do we define an arrow function with parameters? So let's see what we're doing here. We've got an array called myConcat. It's a function that takes two parameters, two arrays, and it calls concat on with array 1 and concatenates array 2 onto it. So if I console log myConcat with 1, 2, and then 3, 4, 5, that prints us 1, 2, 3, 4, 5. So that's good. Now we want to redefine this using an arrow function. So let's take this one step at a time. First, we're going to remove the function, and notice I'm leaving the brackets with the two parameters. So that stays. So two parameters, arrow, and this is a one-liner. So just like last exercise, we can remove the return, we can remove the curlies, and put also in one line. So that's how we do a one-liner arrow function with multiple parameters. Again, keep those questions coming, folks, and we'll answer all of them at the end of the lesson. But please, 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 please do ask them, because these are great questions. We just have a lot of material to cover. So let's run our tests. I forgot you should replace the var keyword. My concat should be a constant variable by using const. My bad. There we go. Whew. Let's run it again. Thank you, Druville. I did miss const. So, pat, we did it. Let's keep going. All right. Here's something funky we can do. Set a default parameter. Now, before we do any of that, I want to define my own function, if I may. So I'm going to leave this out with a comment. Line 2, so that it doesn't run. Let's make our own function. Const print name, and it will take a yes, and it's a function that takes one parameter, which is name, and it'll be an arrow function, and it will return no, it's not going to return anything, so I'll make it a curly bracket one. Console log hello and plus name. Now, let's console log. Oh no, we're not gonna. We're gonna print name, and we're gonna call it with look at that, hello, comma undefined, which is great. Now, that's all well and good. However, what if we want to always have a default? So if I don't pass it in, because let me try with JavaScripters. That will print out hello, comma JavaScripters. But again, if I don't pass in a parameter, it'll be undefined. Name will be undefined. But what we can do is using equals, we can set what's called a default parameter value. World. So now let's see what happens. We will be able to always, if we don't have a parameter, it'll just say like, okay, I'll just default to world. If I do pass one in, however, if I go with something with G, okay, fine, we'll go with Gerald. For fun. Now instead of printing out world, it's printing out hello, comma Geraldine. So this is a backup, just in case there is no value. So I hope that helps. Now, let's move on to our function here. Here we've got a function called increment, which takes two parameters, number and value, and it returns number plus value. Let's modify the function increment by adding default parameters so that it will add 1 to number if value is not specified. Console log increment 1. No, 5. So now it's saying not a number because we're trying to add undefined to 5. But what we want to do is have a default value for value. Let's make that 1 as the instructions say. Now it prints out 6 because it's saying, okay, I'm calling this function. This parameter hasn't been passed, so I'll default to 1. But if I do change it, let's make it 2. Then it'll add 5 and 2 to make 7. So that's how that works. That's how having default parameter values works. Let's run our tests. Fingers crossed. There we go. Pat. Let's keep going. Now we're going to use the rest parameter with function parameters. This is funky. Hope everybody's staying hydrated. Talking a lot makes my mouth a little dry. So what do we got here? We've got a function called sum that takes 3 parameters, x, y, and z. We will define args to be an array made up of x, y, and z. So far, so good. Then we're going to call this args.reduce. Oh, my goodness. Let's see what that does. Don't worry if you don't know what reduce does. We will cover that eventually. So let's console log sum 1, 3, 1, 2. That'll give us 6. So the sum of 3 plus 1 plus 2 is 6. So what it's doing here is just as a shorthand, it's looping through all of the array and summing up its values starting at 0. Don't worry if you don't know what this means just yet. We will cover reduce later on when we get to functional programming. For now, let's just go with the assumption that this sums up all of these parameters. What we can do, instead of saying, hey, give me a value called args, which is an array made up of these, what we can do is actually remove this and just say, use the dot parameter. And this is called the rest parameter. So all of these arguments will be just smushed into an array. Let's try it. What if we do just 3 and 1? 3 plus 1 is 4. What if we do 3, 1, 4, 5? 8 plus 5 is 13. So again, this rest parameter lets us smush everything into an array because we don't care what X, Y, and Z, what about these. We're not going to use X, Y, and Z. We're going to use the array. Whew. So again, with the rest parameter, we can smush all of our parameters into an array. What if we just do 1? Well, 3 plus nothing else is 3. It's just an array with one member. What if we do nothing? It's an empty array. So the sum of an empty array is 0. So that's what the rest parameter is. So let's see what our exercise is. Modify the sum function using the rest parameter, which we did, in such a way that the function sum is able to take any number of arguments and return their sum. We did it. Let's run the tests. And good to go. JavaScript is like learning magic. I agree, Rajesh. Again, keep those questions coming, but we're going to answer it. We're going to answer them at the end of the session. Let's submit. Pat. I didn't forget. And move on to the next one. And folks in the chat, if you know, actually, this is something I've been meaning to talk to all of you about. If you know the answer to some of these questions that are coming up in the chat, please answer them in the chat. Help me out so that I can cover everybody, so that I can cover as much ground as possible and help out your fellow learners so that they don't fall behind. Much appreciated. Okay, what do we got next? Next up is the spread parameter. What we can do with the spread parameter is grab the contents of an array. Just say, hey, give me all of the contents of the array. Here's what it means. Let's take a look at this array here. Const array 1 is Jan, Feb, Mar, April, and May, the first 5 months in an array. Now, what we want to do in this exercise is copy the contents of array 1 into array 2, but copy the contents, not the array. We could, for example, say array 2 is equals to array 1. And console logging array 2 will give us that. But we're copying the array. We want to copy the contents of the array. And we'll do that using the spread. I like the name because it's very similar to the rest that you saw in the last exercise. It's just kind of de-smushing. Yes, I do speak English. I'm kind of de-smushing all of the contents of the array and putting them into a new array. So you might be wondering, why do we need the square brackets? And that's because, again, we're not copying the array, but the contents. See, this is giving us an error. It only works in place, like in an argument. So we need those square brackets to say, hey, this is a copy of the contents of the array. So that's the spread. We're going to be doing a little bit more of spread stuff, so don't worry. Let's run those tests and see how it goes. Yep, pat. Let's submit and keep going. We are 28% done through ES6. This is moving much faster than JavaScript Basics. So now we're going to be using destructuring to extract the values from an object. Let's take a look at this object here. We've got an object called high temperatures, which is made up of 3 parts: yesterday, today, and tomorrow. 3 keys, sorry. And those have a value of 75. Today is 77. Tomorrow is 80. Now, if we want to get those values and assign them to a new variable, we're doing that here. Const today equals high temperatures dot today, and const tomorrow equals high temperatures dot tomorrow. But here's what we can do. We can use destructuring to be able to just do that in one line. You're going to see that in just a sec. Let's console log today and tomorrow. 77 and 88. This is what we want to match. What we can do, I'm just going to comment these out to leave them there. We're getting an error. Today is not defined. So, log, yeah, what we can do is use destructuring. The way that works is we say today and tomorrow is equals to high temperatures. Did I do this wrong? Of course, forgot my const. My bad. Yeah, so we're defining a new const and we're using destructuring to say, hey, from the high temperatures objects, just give me today and tomorrow and put them into these 2 variables, today and tomorrow. You'll notice we don't care about yesterday. We're not using yesterday. We just want today and tomorrow. And that gives us the same values. We can put in yesterday, certainly. If we console log, let's do that. Yesterday. That gives us the value of yesterday as well. So let's remove that. So now we've moved today and tomorrow into destructuring. Let's see our exercise. Replace the 2 assignments with an equivalent destructuring assignment, which we've done. It should still assign the variables today and tomorrow, the values of today and tomorrow from the high temperatures object. So again, we've extracted those using destructuring from inside high temperatures into these 2 new variables. And these are both constants. Yes, as Boris says, thank you very much, Boris. Both of them are constants. Today and tomorrow are both constants. All right, well, we've done it. Let's run our tests. Hey, pat. Nice, let's keep going. Now you might be wondering, okay, so what if we want the variables to have different names? Let's take a look at this example here. High temperatures, we've still got yesterday, today, and tomorrow. But here we're calling the variable high today and high tomorrow to be today and tomorrow from high temperatures, respectively. So let's console log high today, high tomorrow. It sounds like I'm saying hello to today and today. Hi today, hi tomorrow. Okay. All right. We got this. So what we want to do here is use destructuring once again. Let me see if I got that right. Replace the 2 assignments with an equivalent destructuring assignment. But instead of using high, of course, we can't use today and tomorrow because we want to call these variables differently. What we can do is use destructuring, but in a slightly different manner. So there we go. Let's comment those out, call a const. Now what we can do is say, pass the value of today to high today, and pass the value of tomorrow to high tomorrow. It's very confusing to say that, high today. Anyway, high temperatures. Now, what we've done here is use destructuring to be able to assign the values of today and tomorrow to high today and high tomorrow, respectively, which makes for a nice one-liner. Makes me very happy. I'm lazy. I like one-liners. As long as they're legible and not very long. Oh no, I'm out of water. Anyway, so that's what we're meant to do in this exercise. Let's run our tests. Yep, awesome. Pat. Cool. We are doing well. I'm very happy. Now, we're going to be doing nested objects using destructuring because we can do the same thing here. For example, let's look at our local forecast now. We got yesterday we got 3 objects, yesterday, today, and tomorrow, each one with a low and a high. So we want low today and high today. Now, we want to be doing the same thing, but with destructuring. And in order to do that, I'm going to console log as always. Low today, high to today as well. Cool. Low today is 64 and high today is 77. So far, so good. Now, how do we do this with destructuring? It's very similar to how we've seen it before. Whoopsie daisy. There we go. We will be using a const. And with destructuring, we're going to go with today. And then inside there, we're going to be doing more destructuring. Low is low today. And high, oh, wait, am I? Yeah, I'm doing this right. High is high today. Is equals to local forecast. Woof. Let's take a look at this. You know what I like to do when I'm doing destructuring stuff like this? I hope I can do this. I like to put it on multiple lines. It just makes it a little easier to read for me. Yeah, I like that. It makes me happy. There. And here I can understand it a lot better. So we're destructuring today and low to be low today and high to be high today. And it's as easy as changing one of them to be able to change it to say tomorrow. Boom, 68 and 80. Go back to today. And I believe our exercise is to do what we just did. Nice. So low today and high today using destructuring. Let's run our tests. Yep. Pat. Nice. Let's keep going. Now, we're going to be using destructuring assignment to assign variables from arrays. Oh, we're going to be doing some destructuring of arrays. So let's see what we have to do here. Use destructuring assignment to swap the values of A and B so that A receives the value stored in B and B receives the value stored in A. Cool. So we're going to be doing destructuring like before. A, comma, B will be equals to B, comma, A. Let's console log A, comma, B. Let's comment this out first and see what our initial value is. I got a little ahead of myself. Sorry about that. This stuff excites me, so I got a little bit ahead of myself. So A has a value of 8 and B has a value of 6, which we can see logged here. But by using destructuring like we did here, we were able to essentially swap their values. So we're saying A is now equals to B and B is now equals to A in a nice one-liner. Forgot my semicolon. So A is now 6 and B is now 8. Whew, that's funky. But that's how we can use array destructuring, very similar to object destructuring, to be able to assign variables on the fly in a nice one-liner. And that's exactly what we're supposed to do. So let's run our tests. Yep. Pat. Nice. Look at that. We're 41% of the way. Cool. Now, we're going to be using destructuring assignment with the rest parameter to reassign array elements. What does that mean? Let's see here. We've got the variables. We've got a variable called source, which is an array with the numbers of 1 through 10. And this function removes the first 2. And it says const r equals list, and it returns r. Okay. Const r is equals to remove first 2 and that array. Let's print out, let's console log r. What do we get? We get an array of 1 through 10. But what we want to do here is use the destructuring assignment with the rest parameter to perform an effective array prototype slice so that R is a subarray of the original array source with the first 2 elements omitted. What that's saying is, hey, give me this same array, but with the first 2 elements removed. Now we could call shift twice, but we can actually use destructuring in order to do this. And the way to do that is by saying, using destructuring, we'll say A, comma, B. Oh, no, sorry. I'm doing this complete. I'm sorry. I'm not on top of my game today. Please disregard what I said. We're using destructuring here on this side. My bad. So we want A, comma B, and then the rest of R. The rest will be assigned to R. So we're saying, hey, take this array and destructure it so that the first element is assigned to A, the second element is assigned to B, and then the rest using destructuring is assigned to R. And as Juan says very correctly here, we don't even need to specify A and B. We can just remove those. It's just saying, hey, ignore those first two and just give me the rest. If I want to do 3, I just go with 3 commas or 4 commas or 5. And notice, look at the numbers go away one by one. That's fun. So that's how we do array destructuring. Thanks, Juan. Cool. So that's how we use array destructuring to remove the first 2 elements of a list. Now, I believe that's what we've done here. So let's run our tests and fingers crossed. Hey, yes, pat. All right, we got time for one more today. So use destructuring assignment to pass an object as a function's parameters. Ah, nice. Yeah, so let's take a look at what we're doing here first. We've got a function, an object called stats, which is made up of 1, 2, 3, 4, 5, 6. Can I count? Yes. 6 properties: max, standard deviation, medium, mode, min, and average. And these are all made up of numbers. Now, if we look at this function here, we're saying half. Let's console log that. Console log half. Whoopsie. There we go. I forgot to call the function with my smooth brackets. Oh, I forgot to pass in stats, didn't I? There we go. So we're calling the function half with a parameter stats that that returns stats max plus stats min divided by 2. So that's a half. That gives us 28.015. I'll believe the math. Now what we can do is, instead of doing the tedium of stats.something else, what we can do is use object destructuring to be able to do this. Right? Now what we're doing here, I'm just going to remove that stats dot. What we're doing here is saying, hey, it's one parameter, it's an object, and I don't care what else is in it, as long as there's a max and min property. Right? So again, no matter what's in it, as long as there's a max and min, assign that to local variables and use those accordingly. And it checks, okay, there is a max and there is a min. I'll work with that. And this is what's called argument destructuring. And I love this feature because then I can then I don't need to go back and worry about what was this function made up, this object made up of. I just care that it has a max and it has a min. And I believe that's our exercise. Have to send only max and min inside the function. So that's how we can use destructuring to be able to get the arguments out. What if Winston asks, what if there is no max or min? You know what we're going to do? We're going to try that out right now and find out, because I'm not sure. Aha! Not a number. Why? Because max is a number, 56.78. Min is undefined. Number plus undefined is not a number. So that's how that works. Let's submit our thing and see if our tests run. Yep. Pat, we are 48% of the way done with ES6. So we're going to stop there for today. And I'm going to assign you ever so slightly a little bit more homework. Don't stress. Do this at your own pace. This is a bootcamp for you to be able to learn at your own pace, and I'm here to guide you in any way I can. So before I start the Q&A, I just want to re-address the homework. Your homework is to finish the remaining exercises in basic JavaScript. So as many of them as you can. Second, we will do ES6. You will do a couple more of these. They will have to do with destructuring. And I believe, where is my, oh, no, we actually got as far as I wanted to get. Nope, there's no homework for ES6. Tomorrow we will start at create strings using template literals. So again, the homework for tomorrow is to finish basic JavaScript. And tomorrow we will start at create strings using template literals. Now, I know that sounds like you'd like more homework, and I appreciate that, but I want everybody to follow along, and I want to start at string template literals tomorrow. That's it. Tomorrow I'll give you more homework. Okay, so with that, the lesson is done. Congratulations, we are on time. Let's do some Q&A. And we already have one from Joel. What if there are two const objects that both have max and min? Let's go back in here. I think you're talking about this one, right? What if there are two const objects that both have max and min? Const, let's call this stats2. And let's make it a copy of this one. This one only has max and min. So let's console log half stats. Will give us this one. Let's do our destructuring for max and min. Destructure. So here we are. If we have another object and we want to try that one out, we just pass that object as a parameter. Straightforward as that. Folks, if you are lost, don't worry. The recording will stay on YouTube. Ask all the questions you can, please. Let me throw up some links real quick. We've got the forum. Come and ask your forums. There's also a Discord server. I try to answer there when I can. We're all learning together. We've got 6 weeks and a lot to cover, so I know it's a little bit fast, but it's also meant to go at your own pace. Cool. What do we got? Here we go. Can you ever use let with an arrow function? Yes. Yes, you can. The reason we don't, I'm just going to delete everything in here. Let sum equals function that prints out 1 plus 2. This isn't the best function ever. Sum will print out 3. This can be a const, this can be a var, this can be a let. Remember, the difference is that consts only get assigned a value once. That's it. So let's please explain again recursion, but in a layman way. I failed to understand. I know. And I apologize. I want to do this well, so let's go through it once more. Let's go back to that recursion exercise I did. So we're using an array to sum up all of its values. Console log 1, 5, 10, and n, which is 3. It's going to be the length of the array. And of course, I need to call the function. I do sum of this. Oh, whoops, forgot a square bracket. Cool. This is giving us undefined because it doesn't return anything. Now, there are 2 ways to resolve this, be able to sum up all of the members of this array. We could loop through it using a for loop, for example. I must be smaller than r.length. I plus plus. We'll say let result equals 0. Result plus equals our member at I, return result. About to say let. Let I equals 0. So this is one way to be able to sum up all of the members of the array. The other way to do it is using something called recursion, which involves calling the same function, but with different parameters. So we will be using n to track which parameter we're at. That's the which member of the array, which index we're at. That's the secret sauce, so to speak. We can do that by first having what's called an escape, a base case. If n is equals to 0, we will return 0, because you don't want to go any further back than that and just start at 0. Next, we want to return the sum of the same array, but at the index n minus 1, plus our array member at n minus 1. Now, the reason that this gives us the same result is we just need to sort of track what we're doing here. If we disregard lines 3 through 5 for a moment, we call it with this array and 3. So the array always stays the same, but the 3 will change. So 3 is not equals to 0, we skip. Then we add the array at 2, which we know to be 10, plus whatever the result of this is. So then we call this, n is now 2, we call again. And we're just kind of inceptioning in and in again. So n minus 1 is now 2. 2 is not 0. So array at member 2 is, array at member 2 minus 1, which is 1, is 5. So we're adding 5 plus array and 1. We go back up. We're still inside. We're sort of going inside in like an inception kind of way. So n is now 1. N is equals to, and 1 is not equals to 0. We will add this, which is the first one. So 1 minus 1 is 0. The array member at position 0 is 1. And then we call array the same sum function again, n minus 1, which is 0. N is 0, so we return 0. So we now come out a layer. 0 plus 1. Then we come out a layer again. 1 plus 5. And we come out another layer. 6 plus 10. And then we're out. 16. Try it out. Let me see if I've got that article. I got a free code camp recursion JavaScript. There was a great article in there that I am going to paste into the chat here and ask my wonderful assistant if they can paste it for me. But it seems like Google is down, or DuckDuckGo is down too. I don't know. I can't seem to be able to open it. Sorry, folks. Let me see if I can get that. Whoops. Sorry. Give me 1 second. Let me see if I can get that link. I really want that link. Yeah, now I've got it. So I'm pasting this into the chat. So take a look at this. And again, ask questions in the forum, ask questions on Discord. That's why we're all here to help each other. Hope that helps a little bit. Could I explain the object function again? Yes, totally. Let me go to that exercise real quick. Scroll. I'm scrolling mighty fast. We've done a lot. I'm happy with us. We can use object.freeze to be able to freeze an object so that its contents cannot be changed. So what we're doing here is changing mathconstants.py to be 99. If we call object.freeze math constants and we get an error, we cannot assign to read-only property pi of object. Let's remove this complex thing and do it on our own. Const my dog. is equals to name Gregory. So if we change my dog.name equals Wilfred, and we console log my dog, you can see the name has been changed to Guilfred. But if we do object.freeze on my dog, now we get an error saying, hey, you can't change a read-only property. Hope that helps. Does recursion have something to do with performance? I don't know. It could be. I think that falls to the number of actions you're taking. So if you're doing lots of subloops, for example, you will need to do that many n. Let's say you've got an array of length n and an array of length m inside it, and you need lots of arrays length m inside it. You'll need to do n times m operations. Depending on how you do that with recursion, it all depends on how you want to write it. Sometimes it's helpful if you don't know how deep the onion layers go. Let's see what else we got. Trying to see lots of questions today. Why does it cut from the left? Why does it cut from left, not right? That's a good question. Can we cut from the right? I'm not sure. Let's see we've got an array called R. I always like it sounds like a pirate. R. 1, 2, 3. And let's const comma rest remaining equals R. Console log remaining. So we've added a comma to say, give me the first one, remove the first one, and spread and destructure the rest into remaining. But what you're asking is, can we do it from the right? And to answer your question, I'm not sure. I guess we should put the comma after. It would appear not. I highly recommend checking out the MDN web docs. They're super helpful. If my assistant could please bring up that banner real quick. Here it is. Oh, sorry, I clicked on it too. Yeah, check out the Mozilla MDN web docs. You'll find lots of documentations on these things we're covering here. Let's see what else we got. How can I access JavaScript on my website? Whew, this is a big question. So what we're doing here, as you've probably seen so far, is accessing JavaScript inside the sandbox of Free Code Camp. But if you go into your web console, for example, what I usually do is right-click and go on Inspect, and then go on Console. You'll be able to see the console, and there you can interact with the JavaScript running in your browser. Be very careful. If somebody gives you some JavaScript and tells you to paste it in there, do not. It could be malicious code. I don't want to scare anybody, but it could be. So Rio asks, should we always assign unique names for every variable, parameter, or properties? It makes sense to do so, I think, because, for example, with const, that will give us an error. If we try to define with let, another one, that'll also give us an error. What else we got? In your professional life, how often do you encounter recursion? Does the context here reflect the real world? How often? That's a good question. I have encountered it in real life. It is something you encounter, for sure. That, without saying. Do I encounter it often? I would say often enough to require me to understand it. I'd say, depending on the project I'm working on, if I need to, for example, parse a lot of data, if I need to process a lot of data that could go down in several layers, lots of different subarrays, for example, then I could need recursion to be able to understand what I'm doing there. I hope that answers your question. Again, yes, thank you. Mozilla's MDN web docs is a great resource. What else we got? Do we want If you can, please explain the counting cards from basic JavaScript. Sure, let's cover that. Let me go back. Now the counting cards, you know what I'm going to do? I'm going to press Control F and look for counting. There it is. Counting cards. Yeah. Oh, actually, I will say I covered this in the Q&A for yesterday's session. So it might make the most sense, just so that we can get to everybody's questions. I will recommend to you that you check the recordings during yesterday's Q&A. I believe I covered it. Just so that we can get to everybody's questions. I'm very sorry. But what I'll tell you, I'll give you a hint. Two things. First off, switch statement and if statements are your friend. Second, if you get stuck, go to get help. There's get a hint, get a video, and ask for help, and you'll find solutions there as well. Ask the forums, ask on the Discord. Sorry to not be able to answer your question directly, but what you want to do is use a switch statement to be able to figure out if count should go up or down, and then use an if statement, depending on whether count is positive or negative, to return hold or bet. So what else we got? Recursion, Saichan asks, recursion is basically like a brick wall. I don't want to say a brick wall because it is something to overcome, and it'll require some messing around with. What I recommend is the resources, the link I sent in the chat. I'll send it again just in case. Do I still have it in my copy paste? I do. Read up on it, practice it, take a look at what I did in the exercises today again, and work with your colleagues, forums, Discord. So what else we got? Recursion. Carlos makes an excellent point. Recursion can be dangerous. It can lead into this infinite loop that we saw today, and it might not be the most legible. So use it when you need it. In my opinion, if you can do what you're doing with recursion with a loop, go for that. Johannes asks, what is the efficiency of recursion? In the 90s, I used Pascal in my studies. Oh, awesome. And I loved using recursion, but it was said that in PCs, recursion is not that efficient. Is that still true today? I don't know enough to be able to answer that. If somebody in the chat knows, please do look in. Please do. I encourage you to ask. It could be that the way JavaScript processes and calls functions, adding layers onto the stack of memory, could make that slower. That's an excellent point. Thanks, Johannes. Sherry's asking, you said something about security. I've been in computer architecture with Professor Under Mutlu, and the number one concern we have is rowhammer. Your thought, please. I'm very sorry. I don't know what rowhammer is. Is that an error of sorts? I'm very sorry. I don't know the answer to this question. If somebody else does in the chat, please feel free to chime in. Let's see what else we got. Carlos asks, could you do more spread destructuring examples? Sure. Let's mess around with spread and destructuring. We'll do a couple and move on to the next question. So let's say we've got an object, const. Let's do my dog again. I like my dog. Name is Guilford. Legs is 4. Age is 2 years. Dog years. So what we can do with destructuring is be able to say name and legs is equal. Oh, forgot my const is equals to my dog. With that, we can extract the value name and legs from my dog and put it right into these variables called name and legs. What am I doing? Oh yeah, Guilford 4. So that's how that works. With destructuring, we can also do this with arrays as we saw before. Let's do one. Const r 1, 2, 3. We can destructure this array to say A, B, C is equals to R. What we can do there is being able to say, let's print those out, and those will be assigned accordingly. 2, 1, or 3, 1, 1, or 1, 1, 1. Cool. What do we got? When we did new date, you mentioned it's a new instance in a class. I think so. I don't quite have that off the top of my head, but what we're doing is let's console log. Let's not worry too much about the new keyword yet. But what we can do is say, hey, with new, we're creating a new instance of date that will be initialized. We will cover this, I believe, tomorrow. So I'll have a better answer for you then. But again, we're getting ahead of ourselves and we'll have all those answers shortly. Sherry's asking, following up. No, under the threads between the CPU or GPU, any movement can be a security movement going to MOFs fit to a cache under security hardware. That's fascinating. I remember learning about this in university, but I'm afraid I'm not very well knowledgeable on these threads of about this movement of threads there. I believe most programming languages nowadays handle this threading aspect to be able to do so properly. But again, don't quote me on that. I'm not a full expert. Even I'm still learning. We're all still learning. Cool. Ashley asks, got a question on the function parameters const function ABC. How do we define the parameters and how do we know if certain parameters are predefined in JavaScript such as R? Oh, what a good question. Thanks, Ashley. Let's define a function. Function. Let's make an arrow function. Const. Let's call it sum, and we'll make it an arrow function as we learned today. We'll go with A, B, C. Right? Cool. What will happen is that when we call this function sum, we will pass 3 parameters to it. The value of these parameters will be assigned to these locally scoped variables A, B, and C. So return A plus B plus C. If we console log sum of 1, 5, and 10, this just give us 16. So you're probably wondering, can I access A, B, and C outside of this function? The answer is no. Console log A is not defined. That's because these 3 variables are locally scoped to the function sum, right? So what that means is, and to the other part of your question was, how do we know if certain parameters are predefined, such as R? R is not actually predefined. If I console log R, it's going to be R is not defined. What I need to do is have a parameter here called R, for example. Let me just, I'm still getting this error because outside here, R is not defined, but inside there, it is. Exactly. As Juan said, R was our variable. Very well put. Much better put than me. What is coarse error when fetching? Woohoo! This has more to do with web development with JavaScript. So in this bootcamp, we're covering just the JavaScript language itself, but I can give you a little bit of an insight into it. Coarse error when fetching means that you're trying to do an asynchronous JavaScript request, web request, from another URL other than the one you're in. I could be wrong on that. There is material on coarse errors in MDN. Hope that helps. Saichan asks, Are arrow functions only used for short functions, or can they also be used when function is longer? As you can see, oh, that's a good question. You can absolutely make them longer. It's like a function. It's only that if you want to have a one-liner, you can remove those curly brackets, for example. Totally. Nisari correctly says, CORS is short for cross-origin resource sharing. Thank you very much. Completely forgot the name of the term. And Juan says, you can, to answer your question, Ashley, you can check reserved words for which ones are reserved within JavaScript. So some are reserved, and I believe there's a list for it. I don't have that with me. Reserved keywords JavaScript. Let's see. Is there an MDN? Doesn't look like there is. Ah, yes. Here's a link to MDN where you'll find the list of reserved keywords. Sorry about that. Okay, so Fiona, scoping variables and functions is still confused. Please explain once more. Absolutely. What that is to say is that within this function, we can access the variables A, B, and R, which are given value based on the parameters we pass to them when we call that function. We will be able to access the value of these variables inside this function, but not outside. So for example, let's console log C, which we saw was defined in line 2. However, because it was done inside the function, it's not available to us outside of it. Hope that helps. Jay asks, what does the reduce method do? Okay, let's do that. A little bit more advanced, and we will get into it, but I'll give it a try. Let's have an array called R, called 2, 5, and 7. Folks, if you're watching and you're confused by what we're about to do, don't worry, we'll be covering it later on in the bootcamp. So what we have a function available to arrays called reduce. And what we can give to reduce is a function. It says, give me A and B. So 2 members of that array at a time. And we will return A times B. And the second parameter will be 1. Let's console log const. Product is equals to array.reduce. We give to it a function that has 2 parameters. We do something with that parameter. Let's rename A and B, though. Let's call it item and current. You'll see why in just a second. So what it's doing is doing a loop through all of them, through all of the items in the array, getting the item. Oh, sorry, that's the way around. Current item. My mistake. Sorry, I went the other way around. So at the moment, oh no, I did do it. Oh my goodness, I'm sorry. I'm very sorry, folks. I'm doing this all wrong today. There we go. So the first is the current and the second one is item. So console log item and current. And you can see through each part of the loop, we're saying we're checking each item of that array. And then current is a temporary variable where we store what the result of this reduce is. So 1 and 2, 1 times 2 is 2, and 2 gets stored into current. So we go again with 5 and 2. 5 times 2 is 10. Current is now 10. 7 and 10. 7 times 10 is 70. Don't worry. We will try. We will get through this when we get to functional programming, and we're a little bit more comfortable with anonymous functions, which is what these are called. But that's essentially what it does. I like what you put here. Thank you very much. Transform a value based on the accumulator. So that's all the answers I have for now. I'm afraid I'm going to have to leave you all, but I want to say thank you so much for joining this lesson again. Hope everything made sense. Don't worry. There's a lot that we're going to cover, but there's a lot of time. Do this at your own pace. Ask questions. Thank you very much. Go to the Bootcamp forum. Go to the Discord. You'll find the Discord there as well. And if you know the answers, don't be afraid to try explaining them. Explaining this stuff is hard, as you can see. To the rest of you, I want to say, to all of you, what am I saying? To all of you, I want to say thank you so much. Have a wonderful rest of your day, and see you tomorrow when we do the rest of ES6. Have a good one. Bye now.